Welcome back to this new video. In this video I am going to analyze the Cournot model and the Nash equilibrium of Cournot model. Cournot anticipated Nash's definition of equilibrium by over a century ago. Not surprisingly, Cournot's work is one of the classics of game theory. It is one of the cornerstones of the theory of industrial organizations. In this video, I am going to analyze a very simple model of Nash equilibrium where there will be two players named as firm 1 and firm 2. And the strategy for player 1 as well as for player 2 or strategies for firm 1 as well as for firm 2 is equal to 0 and infinity. Why 0 and infinity? There are of course two players in any duopoly game. For example, in that case two firms. In the Cournot model, the strategies available to each firm are the different quantities it might produce. We will assume that output is continuously divisible. Naturally, negative outputs are not feasible. That is why each firm's strategy space can be represented as S1 and S2 is equal to 0 to infinity. And the market price is given by the inverse demand function is equal to 2 minus Q1 plus Q2, where Qi is the demand for firm I. Cost functions are given as C1 is equal to Q1 and C2 is equal to Q2. Payoffs are simply the profit function of firm 1 and firm 2. To find the Nash equilibrium of this Cournot model, we have to follow some steps. Step 1. Find best responses for any Q2 chosen by firm 2. Find the profit maximizing Q1 for firm 1. In that case, the profit function can be written as like here, and take the first order condition with respect to Q1. This condition is necessary and also sufficient to find a max because U1 is concave with respect to Q1. Therefore, by solving for Q1, we can get the best response for firm 1 given the response of Q2, and this is the best response of firm 1. Now similarly, we have to work on the profit function of firm 2, and taking the first order condition with respect to Q2, we can get best response of firm 2 given Q1. Therefore, to be a Nash equilibrium, best response of two firms against each other must be equal. Now, the solution, it remains to specify the payoff for firm 1 as a function of the strategy chosen by it and by the firm, and now define the solutions for the equilibrium. If we substitute the value of Q2 in Q1, then we can find Q1 star is equal to 1 over 3. Again, similarly, we can solve for Q2 and it gives us Q2 star is equal to 1 by 3. So we can say this is a Nash equilibrium outcome. In order to find the Nash equilibrium outcome of the Cournot game, we first translate the problem into a normal form game, and the strategies available to each player and the payoff received by each player for each combination of strategies that could be chosen by the players. By this way, we can find the Nash equilibrium of Cournot model.